Good morning and welcome to today's webinar. My name is Kira Proctor and I'm the Managing Director of the A. Proctor Group. And today, for our fifth webinar of 2022, we're going to take a look at the radon protection measures in buildings. We originally broadcast this webinar last year, but as our Protect Radon 400 barrier membrane has recently been certified by the BBA, we thought now was a good time to revisit this important topic. If you've missed any of our run of webinars over the past year, you can go back and check them out right here on our YouTube channel or through our Learning Hub at www.proctorgroup.com. You can also book in for follow-up calls with our team of experts or register for further information and physical copies of product information and samples. As always, we'll be following up with a live Q&A session with our team of experts. So if you have any questions for our panel, you can type them into the chat box here, DM us on Twitter at proctorgroup, or email us webinar@proctorgroup.com. Radon is a topic that's becoming more important across the industry, having long been regarded as something that only affected projects in specific geographical areas. Experience is increasingly leading to a more robust approach to assessment and mitigation, drawing on lessons learned in these areas and applying them more widely. Although a failure to mitigate the ingress of ground gases such as methane and CO2 may have more dramatic consequences, radon has long been recognised as a quiet killer, with over 1,000 attributable deaths per year in England alone. So today we'll begin with a look at some background, what radon is and why we need to address it, before moving on to consider the applicable guidance and standards and how we assess these risks. We'll then discuss the protective steps taken and how we can ensure these are applied in a robust and effective manner, both initially and over the lifetime of the structure. This doesn't just mean verification of the initial installation, but also what longer-term monitoring may be required and how any emergent risks can be dealt with. Radon is a naturally occurring, colourless and odourless radioactive gas. It was discovered in 1900 by the German physicist Friedrich Ernst Dorn, who was studying the radioactive decay of radium, itself only discovered by Marie Curie 2 years earlier. This work was expanded by the Nobel Prize-winning Scottish chemist Sir William Ramsay, who identified radon as the heaviest gaseous element, 9 times heavier than air. In ground gas terms, most radon is produced by the radioactive decay of trace amounts of uranium found in certain types of rock and soil. And as such, the levels of gas present are determined by the underlying geology of the site, as opposed to any historical usage or pollution. This type of geology is most common in areas with granite bedrock, such as southwest England, the Peak District, North East Scotland and Northamptonshire. Aberdeen in Scotland, being known as the Granite City, has one of the highest background radiation levels in the whole of the UK. Regardless of geology though, we are all exposed to a certain degree of radiation from a wide range of background sources, both natural and man-made. The radon level in an average UK home contributes around half of our typical exposure, and this level is quantified in becquerels per cubic metre. Legislation requiring action against radon in UK buildings has been in place since 1985, initially for workplaces, but has since expanded to include housing. The average household radon level is 20 becquerels per metres cubed, and even at levels up to 100 becquerels per metres cubed, individual risk remains relatively low. However, if the level goes above 200 becquerels per metres cubed, then remedial action is required. Radon is harmful to humans as the radioactive elements formed by its decay can be inhaled into the lungs, where they continue to emit harmful alpha particles. These alpha particles cause localised damage to the lung tissue, leading to the development of lung cancer. The British Medical Journal estimates that around 1,100 deaths per year are directly linked to in-home radon poisoning, making radon the second largest contributor to lung cancer rates behind smoking. Some sources indicate that at least 1,200 new-built homes per year will be above the safe level of radon exposure and should have remedial action taken. This has in turn led to suggestions that building regulations may need to be updated to include more widespread radon protection. The first step to ensuring that an unsafe concentration of radon is not reached is to understand how the gas enters buildings. There are 7 main routes of ingress for radon, or for that matter, any other ground gas. Through cracked or porous solid floors, through junctions and joints between components, through cracked or porous below-ground walls such as in basements, through gaps in suspended floors, through porous walls and foundations, through gaps at service penetrations and pipes, and through cavity walls. Because of the geological origins of radon gas, there is generally very little scope to remove or neutralise the source of the gas, so barrier and venting solutions are most commonly employed. Limiting the extent of the ingress paths here can however help by reducing the long-term resilience on a barrier and providing additional protection. It's also important from an energy efficiency point of view that airflow through the heated envelope is reduced as far as possible, so minimising the overall porosity of the building fabric should always be a priority. The principal source of radon guidance in the UK is the BRE document, Radon, Guidance on Protective Measures for New Buildings. This document is referenced in Approved Document C for England and Wales, Section 3 in Scotland, and Technical Booklet C in Northern Ireland. There is also extensive guidance available from the Public Health England's ukradon.org website. There you can find help and guidance for householders, employers, professionals, local authorities and housing associations. The distribution of radon producing geology is illustrated in Radon Maps, distributed by Public Health England for the UK and the Irish Environmental Protection Agency. These maps indicate the radon risks associated with a specific location. It's worth bearing in mind here that though there may be issues with the available resolution of the geological data, the basic mapping will typically provide radon levels based on a 1 km by 1 km grid. While it can be in a lot of cases reasonably inferred that a clear grid square surrounded by other clear squares is unlikely to pose much of a risk, in areas with more complex and varied geography, it may be necessary to request a more detailed assessment of the local risk. For most areas of the UK and Ireland, more detailed graphic guidance is available on request. In the UK, the lead agency responsible for this is Public Health England, who also provide this information for Scotland, Wales and Northern Ireland. The Irish Environmental Protection Agency can provide guidance specific to the Republic of Ireland. This site-specific radon potential band determines the level of assessment and protection required. The radon potential band percentage represents the chance of any given building in the area having a radon level at least as high as the required action level of 200 becquerels per metre cubed. The low-risk areas with less than 1% chance of exceeding action levels do not require any special measures to be taken. Sites between 1 and 10% are classed as medium risk and require a basic level or protection, with sites over 10% being high risk and require full protective measures. On medium and high risk sites, testing and monitoring are also advised, which again is due to the highly localised nature of radon requirements, particularly in areas where different classifications meet, or sites which are on the borderline between risk categories. We'll move on to look at the various measures in detail shortly, but the most basic protection level typically comprises a radon barrier membrane within the floor or solum of the building, linked to a damp-proof course in the wall. These barrier systems should extend across the entire footprint of the building, and all overlaps and service penetrations should be fully sealed. Moving to full protection requires the same basic level barrier system, but supplements this with additional ventilation to increase the rate of gas exfiltration. Depending on the level of risk and the precise configuration of the subfloor and foundations, this ventilation system may be active or passive and may require the use of sumps and/or mechanical extract fans. We'll now take a look at some of the protective measures in more detail. While it's certainly true that there are less variables to consider with radon protection than with some other types of ground gas or site contamination, it's still important to ensure the system is well designed and fit for purpose. Ensuring a barrier membrane system works effectively requires the material used to be suitably robust and the system to be well installed. Like other ground gas protection measures, the system is only as good as its installation, and if joints are not properly sealed or the membrane is punctured, then adequate performance cannot be guaranteed. A properly designed and fitted barrier will, however, also function as a damp-proofing membrane. The BBA requires radon barrier membranes to be at least 0.4 mm or 400 microns thick. It's important to remember though that membranes, if stretched, will become thinner, so ensuring the material has good tensile strength and elongation characteristics will make sure that the membrane retains its properties. When installed under a slab, for example, concrete poured on top can exert forces on the material, causing it to stretch and become thinner, creating a zone where the permeation of gas becomes more likely, even if the membrane is still intact and unbroken. Reinforced membranes made from virgin material typically have the best mechanical strength properties, thickness for thickness. While a thicker membrane can certainly work adequately, the additional weight and thickness can make detailing and handling more difficult. Joints in the membrane can either be taped or welded. However, in either case, appointing experienced and suitably qualified contractors is recommended. This ensures a good result is achieved first time without requiring remedial actions to fix any issues arising from poor workmanship. However the membrane is installed, it should be thoroughly inspected prior to covering, as fixing any issues after the membrane is covered is often effectively impossible. This inspection should look for any continuity issues such as unsealed joints, punctures, or areas where the membrane is not adequately supported, for example at boundaries where voids may cause excess elongation. Seals at all surface penetrations should also be inspected, as these details can be problematic on site, particularly if pipes are located near foundations, or if installation took place under less than optimal weather conditions. Finally, although it may seem obvious, it's also important that the protective membrane and any associated accessories, such as DPCs, extend across the entire footprint of the building. This means from external to external, closing off any potential gas ingress points. This includes closing off any cavity walls with a suitably sealed and gas-resistant DPC material. Where it's necessary to move beyond a basic level of protection, ventilation should be introduced below the barrier membrane. This example shows a typical beam and block floor construction with a subfloor void. The gas-resistant membrane is placed over the beam and block subfloor and then screeded over. There are a number of systems and solutions for introducing ventilation to this subfloor area, such as ground-level vent boxes, telescopic vents through external walls, and simple air bricks. Exactly which of these solutions is most appropriate depends on the specific building envelope and relative locations of ground and finished floor levels. Provided the vent openings have sufficient open area to deliver the airflow required, they will also do a similar job. Where to position these openings to effectively negate gas buildup depends to a certain extent on the layout of the foundations and any supporting structure. While the best course of action is to discuss the size and location of vent openings with a specialist, there are some simple rules we can apply as initial guidance. Based on NHBC guidelines, vent openings should typically be placed at maximum of 2 metre centres along external walls and not more than 450 millimetres from corners. The relationship between voids separated by ground beams should also be considered. In ground-bearing slab applications where full radon protection is required, it's necessary to provide radon sumps to facilitate subfloor depressurization. The sumps and pipework are installed under the slab, with gas collected by the sump and ducted to an extract point above ground. This enables a subfloor depressurization system to be installed with relative ease at a later date, should it be deemed necessary post-completion. In a typical house, a single central sump is normally sufficient and will provide extraction over a radius of 9 metres from the sump, around 250 square metres. If the soil is particularly permeable, this may increase to a 15-metre radius, but this would require project-specific assessment. If the area under the slab is subdivided, for example with foundation beam or other compartmentalisation, a separate sump may be required for each compartment depending on soil conditions. At the minimum, pipes or air bricks in the subdivisions should be provided to ensure the sumps can provide adequate extraction. If multiple sumps are used, they can be connected with a manifold system and ducted to a single extraction system. This extraction system creates the depressurization that removes the gas. Most commonly, this is a powered or active system where an electric fan is used to drive the extraction. While it's possible to use a passive system without a fan, active systems are more common. This is because the depressurization aspect of the ventilation system is generally only used if post-completion monitoring shows that it is required. If this is the case, a fan can easily be attached to the built-in pipework to provide this. Passive systems typically require more forethought and complex pipework taken through the building to high-level extract points to create a passive stack effect. In either case, however, it must be ensured that gas is extracted to a safe location away from opening windows and ventilation system intakes, with all pipe joints solvent welded rather than push fitted. If a powered fan is to be used, it should be located as close to the end of pipe run as possible to ensure the pipework is kept under suction, in order to prevent any gas leakage in an unintended area. This is particularly important if pipework is to be run through the living spaces in a dwelling. Whatever the construction, if ventilation is required, it's important to ensure it's done right, as systems which are ineffective can lead to high gas readings and complex remediation. Conversely, an over-engineered system can increase timescales and costs with no particular benefit. At the A. Proctor Group, our experienced technical support team can assist in the specification of these systems, reviewing drawings and site investigations to ensure a suitable solution is specified and optimised to fit the individual project circumstances. While it may seem pointless to provide protection to an extension when there's none in the existing building, a subfloor depressurization system can help provide some degree of protection to the existing structure. By locating the new sump and extraction pipework adjacent to the existing structure and knocking through the existing wall, space for a sump under the existing structure can be created. The new depressurization system can therefore extract from both the fully protected extension and also from the existing unprotected structure via the two linked sumps. As well as the above-ground living space, it's important that any basements or occupied underground spaces are protected, particularly as these are at greater risk as gas can permeate not only through the floor but also through the retaining walls. For a typical domestic house, this means the areas in contact with the ground could be several times higher than for a similar house without a basement. This risk is further compounded by the lack of natural ventilation available in spaces below ground level. Alongside this, it's also important to consider waterproofing when creating a new basement or converting an existing cellar. Guidance and recommendations relating to basement waterproofing are given in BS 8102/2009, which also advises on the importance of considering radon mitigation when designing basements. In these situations, it's usually best to appoint a specialist to design and install the combined system, as radon and waterproofing requirements can sometimes conflict. If it's necessary to conduct monitoring of radon levels in a home, this is typically done by using detectors supplied by Public Health England. These detectors are placed in the home for at least a 3-month period to assess the level of radon exposure for the occupants. PHE typically recommend a year of monitoring for new homes in radon-affected areas, and this data can then be used to determine if active measures such as fans are required or if the basic level of protection is sufficient. This is not typically required for extensions. However, if substantial structural work is undertaken or the dwelling is in a particularly at-risk area, it is worthwhile considering. To conduct the testing, PHE-supplied radon monitoring devices are placed in representative areas of the occupied spaces and then returned to PHE for assessment at the end of the testing period. Generally, the detectors are placed in areas like TV stands or bedside tables to give an accurate impression of occupant exposure. They should not be placed in areas which are close to ventilation or windows, or in places away from the main inhabited zones in the dwelling, for example on top of a high wardrobe or on the floor. We'll now move on to take a look at some common installation situations and the difficulties that can arise with each. We've discussed this before in our webinar on brownfield sites, but installation quality is a critical part of ground gas protection, so it's worth repeating here. We'll begin with corner details, which are probably the most common detail present on every site. This corner has been cut and resealed using flashing, but it has been left unsealed at the corner. The membrane has also not been pushed into place properly, so any subsequent concrete or screed pours will overstress the membrane. This may lead to tearing and subsequent gas ingress. In this case, the membrane has not been extended to close the cavity wall, leaving an open pathway for the gas. The membrane is also roughly folded into place, which may cause problems when it comes to installing further courses of brick and blockwork. The most reliable and time-efficient method of getting a good corner joint is to use a preformed corner unit. In most cases, however, these corners will need to be adapted to fit precisely into place. The important part of the corner, the integrity of the actual corner point itself, can be maintained by carefully cutting the corner unit across the middle and sealing both the top and bottom sections into place as shown here. This ensures the corner area remains fully gas tight. Another detail found everywhere is the simple membrane joint. Apparently simple enough, joints between adjacent runs of membrane commonly cause problems. The most obvious problem is the missing sections of sealing tape, creating a path for gas to bypass the barrier, but tape joints can cause other problems. Here, we can see where the tape run has not adhered to the membrane, where the membrane is not sitting flat on the substrate. The most effective method, and that used by the majority of NVQ2 qualified installers, is to weld membrane joints. This not only saves on the cost of tape, but it is far more tolerant of weather and site conditions, as tape adhesion is not an issue. Successful tape jointing requires a clean and dry membrane surface to joint, and temperatures within the tape's operating range, typically 5 to 30 degrees. Assuming these conditions are met, the optimal procedure for a successful tape joint is shown here. By moving the butyl tape joints to the edge of the lap, it becomes far easier to ensure the joint has been done correctly. This positioning of the tape also ensures any concrete screed poured on top of the membrane cannot enter the joint and put additional pressure on the integrity of that joint. Detailing around stanchions is a little more difficult, but does not pose too many problems if the method here is used. The most important thing to note here is that the flashing tape used is of good quality and matched to the membrane utilised. As manufacturers, we recommend and supply tapes that we know work well with our membrane systems, and this advice should be followed. The flashing tape should be rolled into place without leaving gaps underneath. Flashing tapes are usually less resistant to elongation than membranes, so it's important these areas are fully adhered to a properly supported substrate to limit the potential movement. The rounded corners shown here are also important, as these are less likely to lift than a sharp corner and put much less stress on the membrane and tape interface. Although it may seem obvious, it's also important to ensure the gas-tight layer is continuous. If, as shown here, the stanchion is in the centre of a concrete column or pile cap, the entire area must be sealed. Pipe penetrations are another area it's important to get right, as they are a common feature on many sites. These images shown are of the more common problems that can occur. In the first case, the supplied top hats did not fit properly, so the installers have got a little creative. Whilst it's possible that this detail may work to provide a gas-tight seal, it is by no means a given and would be almost impossible to verify. In the second, the smaller pipe appears to have been relatively well sealed, but the larger is not sealed at all and corresponds to a lap in the membrane, creating additional complications. The close proximity of the pipes to each other also makes detailing and sealing using proprietary top hats difficult. Here we can see the correct procedure to provide a gas-tight seal to a pipe penetration, as with columns. This is not particularly difficult to achieve. Again, as with stanchions, ensuring the membrane is cut as little as possible and the top hat is smoothly seated onto the membrane is critical. The flashing tape should be firmly adhered in place and properly supported. The general conditions around a site are often as important as specific details when it comes to validation of membrane installations. In these images, you can see that patches have been applied to the membrane haphazardly and messily. The marker spray is still visible around patches, indicating that the applied patches are too small to give the required overlap. In this case, we can see the structural reinforcing bars laid directly onto the membrane with no protection fleece or board used. This protection is not only important to prevent direct puncturing of the membrane, but also to prevent damage from cutting using saws and grinders. These processes produce large amounts of sparks, which, if they contact the membrane, can melt holes and cause significant damage. So, whilst a small increase in cost per square metre to specify a fleece or protection board may seem unnecessary, the effect it can have in reducing remediation costs and delays is more than worth it in most cases. As with all ground gas protection systems, the critical aspect of detailing out radon problems is making sure the requirements are fully understood, and any implications are factored into every stage of the project, from design to construction, and finally to ensure monitoring if needed. A really important part of this is working with experienced project partners who are familiar with these problems and have a good understanding of how to solve them. With that in mind, we'll now move on to the Q&A session.
Good morning, everyone, and welcome to our live Q&A session. My name is Carol Mikulak, and I am delighted you've joined us this morning. I hope everyone enjoyed today's presentation. And although it was one we covered last year, it's always good to revisit topics, even if you did see it first time round. So just to run through our format for this morning, for anyone new with us, we will stay on here and answer any questions that you would like me to put to our panel. So feel free to drop your questions into the YouTube chat feed, or alternatively, you can send us a direct message to our Twitter page at Proctor Group, or you can email us at webinar@proctorgroup.com. If there's something you'd like to ask, but you can't stay for the whole of this session, don't worry. Just get in touch by any of the usual means, leave some contact details, and we will get back to you as soon as we can. Now, if you have registered for today's webinar, you will get a follow-up email from us, which will include details on how to request your own personalised CPD certificate, as well as a replay link allowing you to watch back the full presentation and this Q&A session. So please forward that email on to anyone you think that might find it relevant and interesting. Please also, if you can, leave us some feedback, give us a thumbs up, and subscribe to our YouTube channel, where you will get updates on anything that we're involved in, as well as details on future webinars. Now, if you'd like to know more about anything at all that we discussed today, see some product samples, or arrange a meeting with one of our team, again, please do get in touch. We're always keen to find out what you're working on. You can also, as Kira mentioned at the start of the presentation, revisit any of our previous webinars from the past 2 years. And these can be accessed either from our YouTube channel here or on our Learning Hub page of the website, www.proctorgroup.com. Now, moving on to our next webinar, which is now available for registration. This will take place 2 weeks today, Friday the 10th of June at the usual time of 10 AM, where we will be presenting another one of our toolbox talks. This time it will be an overview of the practical application of the Space Therm range, high performance aerogel insulation systems, their performance benefits, and best practice for site installations. These toolbox talks really are proving to be very popular. So if this is relevant to you or any of your colleagues, please spread the word and join us if you can in 2 weeks' time. Okay, let's move on now to why you're all here, to our Q&A session. And let me introduce you to our panel for today. And I have a real treat for you with some new faces. First, I'd like to introduce you to Matthew Spiller, who is our National Technical Sales Manager covering ground gas protection. Good morning, Matt.
Good morning, Carol.
Good morning. Next, we've got a slightly more familiar face for you, Paul Young, who is one of our technical advisors. Good morning, Paul.
Morning, Carol. Morning, everyone.
Good morning. And finally, another new face for you. We've got Jennifer Rimmer, who is our internal coordinator covering the ground gas division. Good morning, Jen.
Morning, Carol. Morning, everyone.
Good. Now, I am really pleased to see that we've got questions coming in already on the YouTube feed. That's fantastic. Please keep them coming in. And as always, just bear with me as I'm collating them in from various different sources. So let's start off with you, Matt, if I can. This question's come in on the YouTube feed from Paul. Paul asks, is there a cost for site visits and reports?
By reports, Paul, I assume you mean sign off or validation of the installation?
Technically, radon installations don't need independent validation like other gas protection systems for other ground gases. But I would still advise that you would use an independent verifier. And unfortunately, yes, they do charge it, so they make their living.
Great, perfect. Thanks, Matt. Well, I've got you. I'll just stay with you. Another one on YouTube from Abby. Abby says, it seems quite common for standard DPM to be used to protect against radon. Is this acceptable?
Unfortunate, Abby, you're right. Damp-proof membranes are often installed to prevent the ingress of radon. What worries me the most is that an awful lot of the DPMs are now made from 100% recycled raw materials. And if there's no control and consistency with the feedstock, how can you possibly have a consistent performance of the membranes? In my opinion, a damp-proof membrane is just not adequate. It's not acceptable. Also, the vast majority of damp-proof membranes are multi-folded for ease of transport. This creates a permanent crease the entire length of the membrane, and those can be very difficult to seal to an acceptable standard. So the short answer is no, I don't believe DPMs are acceptable.
Excellent, thanks, Matt. Okay, Jen, if I could bring one to you. Another one on YouTube from Greg. Greg asks, do you install product yourself, or do you have a list of who could install it for us?
So no, we don't actually install our products ourselves, but we do work with a lot of installers. So if you get in touch and let us know either where you are or where your project is, then we can help advise on some approved installers close to where you are that would be able to assist.
Perfect, thank you so much. Okay, let's not leave you out, Paul. Let's come to you for the next one. We'll stick with YouTube questions. Great to see some good ones coming in already. Ellen has asked, oh no, I'm sorry, I'm jumping gun, you go. Yeah, Ellen has asked, sorry, is it possible to provide any level of protection to existing building stock, no basements, in medium and high level areas?
Yes, it is. I mean, it is quite difficult, especially when you're talking about existing housing stock, because, you know, trying to get a continuous membrane to go through all the existing walls, especially to the exterior, you know, it can sometimes be almost impossible. So quite often what you will have to do is effectively seal it up against the existing wall as best you can, normally up to a certain height, typically above the kind of waterproofing line where your DPM would be. Yeah, I mean, I guess sometimes the option is that you need to kind of dig up the existing floor, you know, maybe install some sump systems, core through the walls, to make sure that, you know, you are kind of able to, you know, allow that gas to go into the sumps from all areas of the building. So yeah, it can be quite difficult, but there is some guidance out there. And I mean, if someone wanted to send us an email with a particular project they've got, then we can point them in the right direction, maybe even have a look at the design along with speaking to some consultants about it.
Perfect, thanks, Paul. If I can stay with you for this next one, please, Paul, as well. Daniel has asked on YouTube, how reliable are the radon maps contained within BRE 211 and the UK Radon website? And should these be relied upon when advising on radon protection?
Yeah, I mean, they're good for guidance only, we would say. So, you know, where you've got the 1 kilometre square that was kind of mentioned in the webinar itself, that is, yeah, so it's a 1 kilometre square. Now that indicates the kind of average risk in that area. You'll even find that in the areas that are shown as white, which some people would assume is no risk, what it actually means is it's less than a 1% risk. So, I mean, the best way to know for sure in an individual site or building would be to actually perform the testing. There's not really any substitute for that.
No, yeah, and as Mike's commented there as well, radon maps are only indicative. Yeah. Okay, let's move on. Another one, we'll just stick with the YouTube ones. They're coming in fast and quick, which is great. Matt, if I can bring this one to you from Patio Doors. He says, I've had issues before where installation of a radon barrier creates a slip plane for the whole house in order to ensure coverage over the whole footprint. Do you have suitable detailing to avoid this?
Yes, Paddy, we do. We have gas-resistant DPCs. So they are embossed in the same way as a standard DPC is to reduce the chances of creating a slip plane. So yes, if you're concerned about slip planes, a gas-resistant DPC that can then be joined to the radon membrane would solve that problem.
Perfect, thank you so much. While I've got you, Matt, we've actually just had quite a few emails come in. If I can come to this one, this is an email that's come in from Douglas. Douglas asks, how do I know how many sumps are required for my building? Are there different guidelines for housing and commercial buildings?
Right, okay. The general rule of thumb is one sump will be effective for around 250 square meters of floor area. There are some variables such as, for example, dwarf walls creating separate compartments in the subfloor. Anywhere you need to use more than one sump, you can manifold them together into one system. It allows the entire system to be actively vented by a single fan. And the only difference between residential and commercial radon protection is the action level. That's 200 becquerels per meter cubed for residential and 400 becquerels per meter cubed for commercial.
Perfect, thank you so much. Right, we've just had actually one come in on a web chat. Jen, if I can get you to help here, this is from David. David he's missed most of the presentation, unfortunately, but I'm really interested in this topic. Can you help him?
Yeah, it's no problem. So if you've registered for the webinar, then you'll get an email with a replay link that will allow you to watch the whole thing back again. But if there's something a bit more specific that you would want to discuss with us, we can arrange for a meeting either virtually or in person. We can go through things with you there, or we do have our CPD presentation that covers a lot of the ground gas protection that might also be of interest. Again, if you just get in touch with us, let us know which sort of things will be the most suitable to give you the information that you're after. I'm sure we'll be able to set something up for you.
Perfect, thank you, Jen. If you've missed that bit as well, all our previous webinars are available for watch back as well. So there's lots and lots of content. Don't worry, if you've missed us, you won't lose anything. You can come back and revisit lots. Back to another email. Matt, if I can come to you with this next one. This is an email from Graham. If installing a sump, you have decided to provisionally connect this to the pipework, which will be taken outside of the building and capped off just above ground level, what determines the necessity of connecting the pipework to an external fan and commissioning it?
Testing. The testing, we need to know the average radon levels in that property, which is why the system is put in place to be able to retrospectively fit the active fan. So the passive system really is only suitable with the levels of radon are around 300 becquerels or less. If after testing the radon levels are above 100 becquerels, it's advised that the extraction fan should be installed at the soonest opportunity.
Excellent, perfect, thank you. Let's jump back to YouTube again. Matt, while I've got you, can I ask you this one from Greg? If the standard DPM is inadequate as a radon membrane, is there a radon membrane which will obviate the need for a standard DPM?
Yes, certainly our radon membrane performs as a damp-proof membrane as well. There's no need to install both. I would check with the manufacturer, but as far as I'm aware, most membranes on the market that are suitable for radon protection also work as damp-proof membranes.
Excellent, perfect. Let me jump back to a couple of emails here. Paul, this is a good one for you, if I can come with this one. Emily has asked, are newer, more airtight or even passive house buildings at more risk of elevated radon levels?
Yeah, that's actually a really good question. I mean, the idea of the building being more airtight does mean that potentially gases, take longer to dissipate. But I would say that, if it's properly designed and constructed, following the guidelines in the BRE report, the BR211, then there should be no risk. I mean, we don't really like the idea that, you want to keep your houses drafty just to help protect against radon. You know, you want to make it as energy efficient as possible. Obviously, that's why so many more properties are becoming passive house. So yeah, as long as you follow the guidance, you've got a suitable membrane, potentially sumps, depending on how high the risk is, then no, we would say that it's not a higher risk.
Excellent, thank you, Paul. Let's stick here with another email. Matt, if I can come back to you with this one from Peter. I have just found out that a site I am developing has methane and radon. Should I follow BS 8485 or BR 211? Which is the more dangerous ground gas? Great question.
Okay, good question, Peter. This seems to trip up quite a lot of people. The guidance in BS 8485 and most of the membranes suitable for methane protection would also protect against radon ingress. I'd certainly recommend you check with the manufacturer or installer that the membrane they're proposing protects against both. I would even go so far as to suggest maybe a BBA certification just to get that added assurance that it's been independently checked. As for which is more dangerous, both carry risk to health and even life. And although methane ingress can lead to a more dramatic result, such as an explosion, between 11 and 1,200 people die from radon-related lung cancer in the UK every year. So I would say they're equally dangerous and both should be treated with respect.
Absolutely, absolutely. The silent killer, isn't it?
Absolutely.
Paul, can I come back to you? We've got one here that's come in from Trevor on LinkedIn. He has asked, if my site has high levels of carbon dioxide or methane as well as radon, do I need to incorporate multiple levels of protection?
Okay, yeah, so Matt kind of touched on it there when he said, you know, the sort of protection levels that you get for CO2 methane will very often be suitable for the radon protection as well. So what I would say is, so if you have a low risk kind of radon site, you would generally only need the basic protection, which would just be, you know, your 400 micron barrier. But if the CO2 or methane is at a higher level or higher risk level, then they might also require a ventilation strategy. So in that sense, you would be incorporating, you know, multiple levels of protection, but you wouldn't necessarily use more than one membrane. And what we would always suggest is try and specify a membrane that covers all of those gases, so CO2, methane, and radon. And then, you know, there's obviously a cost saving there if you're, instead of having to put two membranes in the same position.
Excellent, thank you so much, Paul. Matt, if I can come back to you, I've got an email coming here from Luke. Apologies if this seems a silly question. No question is a silly question, Luke. But I do realise the importance of radon membranes in buildings, but what is to stop the radon gas coming into the building through open windows or doors and air bricks? Also, if the gas is heavier than air, presumably it just stays at ground level. But what happens on a windy day? Presumably the gas will still go in open windows.
First of all, yes, radon is about 8 or 9 times as dense as air, but obviously changes in atmospheric pressure causes the release of the radon. Radon entering a building through doors and windows is something we consider when installing an active system. It's why we would vent the radon up just above roof level. We certainly wouldn't vent at ground level for the simple reason that it could potentially re-enter the property. But natural discharge of radon, which is happening everywhere in open spaces all around the UK, it's so diluted in air that the percentages are pretty low. You'd be relatively safe.
Perfect. Thank you, Matt. Let's go back to another couple of emails, if that's okay. Paul, can I come to you with this one? An email from Christine. Do radon membranes require verification under Syria C735, similar to that for methane and carbon dioxide?
Okay, so I mean, the answer to that is actually no. So radon installations don't actually need to be verified independently. In our opinion, would probably say that maybe the current guidance needs to be updated, because as you know, we've already touched on, it's not as if radon is any less dangerous than the other gases. A badly installed membrane, you know, is going to perform poorly. You know, so there's potential, you know, ingress into that building then. The same goes for if your sump system's not installed properly. So the only way to really ensure that the measures you're putting in are going to work is to kind of monitor the installation. I think independence, you know, independent from the contractor installing it is quite important, just to make sure that they are following the guidelines.
Excellent. Thanks, Paul. If I could just stay with you, we've got an email here from Ben. If older buildings are being thermally upgraded and made more airtight, then presumably radon becomes a consideration where previously it wasn't.
Yeah, potentially. I mean, obviously, like we've said before, you're always better to do some sort of investigation and check what that risk actually is. You know, not every old building has just happened to be constructed on a high radon site, so not necessarily. But yeah, you're right. If it's initially the draftiness of the building that's protecting you from the radon, and you go and, you know, insulate and make it airtight, the risk can increase. So yeah, I mean, maybe it would be a good idea, just as a precaution. You might want to put a damp-proof membrane down anyway, so why not make it a radon membrane?
Perfect, thank you. As always, if you're unsure, please just get in touch. That's what these guys are here for. We've got a fantastic team of support up here at head office and out on the road. So if you're not sure about anything, just get in touch with us and we will certainly help out. Now, I've actually got a couple more questions here. We have been firing through these this morning. I know it's a little bit of a concentrated topic, this one, but some really cracking questions coming in there. So if you've got anything else you want to ask us, please drop it into the YouTube feed now, or we'll certainly come back to you at a later date. Jen, if I can come to you with this one, which you'll definitely be able to help from the sales side of things. Joseph has asked, how can I buy your products if I can't buy direct? Something we get asked a lot of. I don't like using the big named merchants as I know they add on a huge markup.
As a company, our standard route to market is through distribution, but we do work closely with the merchants and distributors to help them understand our products a bit better. There are some that we work closer with, especially given sort of the nature of the ground gas protection. They're a bit more specialist. But certainly, if you've got any concerns about someone that you're speaking to, if you don't think you're getting the best price, you can get in touch with us and we can help you based on where you are in the country or who you want to work through, and we can discuss the best option to make sure that you're definitely not getting overcharged and that you can still get the products that you need.
Poor merchants, they get it in the neck, don't they? Right, now I think this is the final question for me, actually, unless there's a quick one, glass one come in. Jen, if I can just stay with you with this one, best place definitely from the sales side of things. Nathan has asked on email, there seems to be stock issues with products all over the place right now, we know. Do you have material available or is there a waiting time for it?
So no, we are actually in a good position with all of our ground gas, but especially our Radon 400, that we have stock available up here. So our standard delivery lead time at the moment is about 3 to 5 working days. We do our best where possible to make that improve on that where we can. But 3 to 5 days gives plenty of time to get material for you.
Perfect. Well, actually, I think that's me covered everything. We really have flown through these questions today. Like I said, some really, really good discussions there, some fantastic questions from you all. If I have missed anything or anyone, my apologies. We certainly will go back through everything, make sure nobody's been missed. And if there has, we will get back in touch with you. If there's anything at all that you would still like to ask us or you think hasn't been covered, or you would benefit from a one-to-one discussion with us directly, as we keep saying, please get in touch and one of the team will get back to you straight away. Please subscribe to our YouTube channel, give us a thumbs up and give some feedback. Every piece of feedback that we get is looked at, it is taken on board, good, bad, negative, whatever you think, it helps shape the future. Please register now for our next webinar, 2 weeks today, Friday the 10th of June at 10 AM, where we will be presenting another toolbox talk covering space therm. So all that's left for me to say is thank you for taking the time out of your busy schedule to join us this morning. And of course, huge thanks to both our panel here in front of the screen and to the amazing team behind the scenes for putting all this together and for the support that they give us before and during the live feed. So from all of us here in front of the camera, and I switched one this morning, please enjoy the rest of your Friday and do have a fantastic weekend. Take care, everyone.